One of the biggest challenges in flow cytometry panel design is selecting the right combination of fluorochromes and antibody conjugates so that the need for compensation and spillover adjustments is kept to a minimum. EasyPanel is a simple, free online tool for flow cytometry panel design. Developed hand-in-hand with leading experts in flow cytometry, EasyPanel is a specialized algorithm that goes one important step beyond what most online tools offer by actually suggesting specific custom and optimized flow cytometry panels based on users' inputs and requirements. While building the right panel is an iterative process that requires experimental validation and testing, EasyPanel offers the best starting point in the process of developing a flow cytometry panel. How does it work? EasyPanel collects users' inputs and requirements, including the configuration of the flow cytometer used, such as the number of lasers and available optical filter sets, as well as the desired panel size. Based on these constraints, EasyPanel screens almost all potentially suitable fluorochromes to determine the combination that offers minimal spectral overlap in addition to the highest possible brightness. The algorithm also takes into account the antigen's potential expression levels on cells in order to pair brightest fluorochromes with dimmest antigens and vice versa. Thirdly, antigens that are co-expressed on the same cell populations are logically paired with fluorochromes that have the lowest possible spectral overlap. Mutually exclusive antigens are antigens that correspond to different cell populations that will be gated and analyzed separately. EasyPanel cleverly matches these to fluorochromes that are spectrally adjacent within the panel. If the user also needs to add other dyes, such as a cell viability dye and/or a cell proliferation dye and/or a cell cycle dye, then EasyPanel would do so by selecting the ones that are most compatible with the optimized panel. Furthermore, if the panel requires cell fixation and permeabilization, then the algorithm would avoid any fluorochromes that are not optimal for these conditions, such as tandem dyes and large fluorochromes. Based on these inputs, EasyPanel methodically screens huge numbers of different potential panels and actually comes up with specific optimized panel suggestions, minimizing spillover and judiciously matching fluorochromes to antigens. What's more, EasyPanel also includes an interactive spectrum viewer tool for users to check and evaluate themselves the spectral overlap between the different fluorochromes at each laser in the suggested optimized panel. As we continually strive to develop even smarter versions of EasyPanel, we really look forward to receiving your feedback and suggestions.